Okay. I would like to introduce Ryan Hobson. And for those of you who will definitely ask, Ryan and I have known each other for a long time because we're old now. But Ryan actually grew up beside my aunt. And then we ended up going to high school together. And in English class, for some reason, I always ended up sitting right behind him. It just kind of happened that way. So that's how I know Ryan. And he is now a civil engineer. And I'm going to let you tell about yourself. Okay. All right.
Okay. Like Heather said, my name is Ryan Hobson. Lived here in Jonesboro for practically all my life. I graduated from David Crockett High School in 2004, so it's been a few years. From there, I went to the University of Tennessee. I graduated from there in 2009. So I've been a practicing civil engineer for a little over 10 years now. I guess I got started or decided on that path really from my freshman year of high school. I decided to take a drafting course that was offered there at David Crockett. I don't know if how many of you all may have taken something similar or have that offered, but I got started in that my freshman year. I guess really starting in my junior year, I started focusing on architectural drawings, house plans. So for my junior and senior year, I did, you know, several house plans. And so for a while, I considered going into architecture, but for whatever reason, I decided against that. So once I did start at UT, I initially actually started out as a chemical engineer. So I took a couple semesters worth of courses, mostly intro courses, and after taking, I guess, the first two chemical courses, I decided that wasn't exactly for me. So I switched over to civil, and that's worked out really well since then. I guess comparing civil engineering to an architect, really the architect is makes a building look how it is. It's more cosmetic, meeting codes, those type of things. The civil engineer, at least from my job description, basically makes sure the building won't fall down. So within the civil engineering discipline, there's 5 or 6 actual categories or focuses that if you were to pursue, you would really typically choose one or the other to focus on it, especially once you finished up school and got into you're starting your career. So the first one is wastewater environmental. So there, if you go that path, you would focus on, water treatment, environmental aspects, stuff like that. So work from municipality, a public works facility in the town or city, something like that. Then the next one is a general construction focus. That would, you'd focus on, construction scheduling. They could also do some testing, whether it's, concrete, steel. There's lots of standard tests that are performed during construction. So you'd be focused on that and project management, keeping everything on schedule, on budget. So that's obviously an important role during construction. Then you have your geotechnical, which will primarily focus on the ground and the earth. So there's a lot of testing involved. You find out what type of soil, rock you're building on. Really, that's the the starting point for any building type of structure is to find out what you're going to be building it on, and then you apply those parameters, factors into your design, and that helps to shape some of that. And then you have the next one is transportation. So that one mainly focuses on design of roadways, intersections. I don't know if most of you are from here, but if you're out in the Boones Creek area, that big construction project going on there. So a civil engineer would have been a part of that design as far as laying out the roadways. There's standard equations, parameters that have to be met as far as, your curves, your widths of roads, stuff like that. Um, the next one is just kind of a general civil. That is focusing on, site plans, your layout, your underground utilities, drainage, stuff like that, get the site ready and meet all local codes. There's lots of that stuff that has to be followed. And then what I'm in is mainly structural. So that's going to focus on, your buildings, your foundations for that. Even within structural, you'll either focus on, buildings, whether it's commercial, industrial, residential even, or bridges. Those are kind of broken up. So you typically choose one or the other if that's the section of the field you want to get into. Um, let's see. As far as typical day for me, it's really dependent on what stage of the project we're in. Um, we're starting out, and this will kind of be dependent on the type of company you're working for. Is you're in your bid or proposal phase where you'll spend some time, looking over the scope of the project you're going to bid on, finding out what are requirements, what you're to be designing, and then from there, you're going to provide estimates, how long it's going to take, cost, stuff like that. Because typically on most projects, you're going to have several different engineering disciplines that are a part of it that will be, contributing, you'll be working with. So that's I guess the beginning stage on most projects is coming up with that and getting your main parameters outlined and set. Then from there, if your company's awarded that project, you'll move into the design phase, and that's pretty self-descriptive. You'll spend, I don't know, anywhere from a couple months to a couple years, depending on the project, working through design, getting it ready to send out and have it be built. And obviously from there you move into the construction phase, and that again can last a couple years depending on the project, the size, and uh, those types of things. And then typically during that stage you'll be answering any questions that come in. If there's any problems that come up during construction, you'll help solve those. You may make visits to the construction site to look things over, supervise. It'll just really depend on your role with the company of what your task will be during that phase. So, and a lot of that, at least the company I work for now, we're strictly engineering. We don't do any construction, so we'll come up with the designs, and then we'll send those out for bid to a separate construction company that will come in and take our plans and design and construct that. Company I work for now, it's a little bit different than what you'll typically find in that. The site I work at is actually owned by the government and ran by the Department of Defense. So my company is actually a contractor on site that's operating the facility for the government. The site is Holston Army Ammunition Plant. It's in Kingsport, Tennessee. It was actually constructed as part of World War II to support the war. After the war ended, it kind of went down for a while and was started back up during the Korean War, and it's been in some form of operation since then. So I guess it was maybe last year, the year before, they celebrated their 75th anniversary of the site being in operation. So it's, like I said, it's a little bit different than what you would see in, a private company, in that you a lot of them will do the construction and the design together. So you'd be working within in the company itself, to do each of those phases. Prior to that, I worked with a local construction company. Most of our work was in the coal fields, coal industry. We did a lot of processing plants, material handling, conveying systems, stuff like that. So, with that company, we really mainly just focused on the designs, and then obviously provided support once we went into construction. But they had a whole separate group that would do the proposals and estimating. So we didn't really have to get involved with that too much. Um, I've actually got some I guess construction pictures of one of the last major projects I worked on there at this previous company. So if I can get them pulled up, and I'll kind of show you what those are. They're showing up for everybody? Okay. So this was a facility, I believe it was in Van Sant, Virginia. It's kind of up in the mountains. It's pretty small area. This facility that we built here was what's called a coke crusher. So they would, convey coal up to the top. It would, trickle down and end up in these big pieces of machinery that basically crushed the coal up into fine dust and powder that would be used elsewhere, I think, to produce actual steel. So what we've got here, you've got your main columns up on the sides, and this conveyor and this big duct here in the middle was actually existing. So part of the challenge on this project was building over top of this and make sure we clear everything and there aren't any interferences, stuff like that. So we'll scroll through these a little bit and get it to work. Okay, there we go. So this is just kind of a side view. This is at the beginning. We've got, the main columns, at least the bottom portion of them, constructed. And we've got the bracing here connecting between the columns. That's really just part of the analysis to decide, what's needed to support it and, to make it pass requirements. It's kind of an aerial view of it, looking up. Of course, as we move on, construction moves on. Down here, you can see these two green pieces of equipment. Those were the actual coal crushers themselves. And I believe this red piece, I think that was one of the motors. Those motors each, I believe, were 1,000 horsepower motors, and I believe they weighed 15,000 pounds each. So, that's just a motor itself weighing that much, and you have this other equipment that was, 2-3 times that weight as well. So that's probably the biggest inputs factors you have to account for when if you get into this field as far as design goes is inputting these loads into your build excuse me, you're building a structure to make sure everything's accounted for um, in the design. There's just kind of a view up on the road looking down. And as construction progresses, they're just different pictures looking at it. So if you see kind of here in the middle, the blue thing there, that was what's called a hopper. What that does is you'll have a conveyor coming up, feeding into the building, and the coal, at least in this case, would actually fill up inside that hopper. Once it got so full, it would, the bottom, they'd open it up and feed onto a different part. Probably here it would feed into the crusher itself. So that was kind of how, you get the material from one point up into the building. Here it's, I think they've got the main structure itself constructed there. They're putting the siding on the building. Yeah, I think in total height, this was about 120 feet tall. So that's, about 10 stories tall. Here's kind of one of the final pictures once everything's been enclosed. So I guess as far as design on something like this goes, like I said, you have your loads that you input into your computer program. That's what's typically used on something this large. So you have your dead loads. Those are primarily, your equipment weights, any flooring, concrete floors, stuff like that. Then from there you have live loads, which are what's called your operating weights. So you've got your equipment. If you've got any tanks or stuff like that, the live loads would be, the water or whatever chemicals inside the tank to account for that weight would be your live load. And then from there you have snow load, which you don't have too much of that around here. You get up north, out in the Midwest, you're going to have a lot higher loads there, which typically that's just accounted for on the roof of your structure. Then from there you have wind loads. Codes change a little bit, but primarily your lowest wind load you design for is 90 miles per hour, and that ranges up to 120 miles per hour in general. Now, you get in hurricane regions, places like that, you're going to have specific parameters that you're required to use. I think you get, down in Florida, in some places, you're getting close to 200 mile per hour winds that have to be designed for, and that's nothing I've done, but I'd imagine that gets pretty complicated when you get into wind loads that high. And then lastly, really is your earthquake seismic loads. Again, around this area, that's not too big of a deal. But even now with some of the newer codes, once you get down into the Knoxville area, they've seen some increase in those. So that's probably the most complicated part of the design is designing for the seismic codes. There's a lot of that even now is pretty theoretical, and so there's different ways that that's handled. If you get in some areas like out in California and I believe Illinois, they require you to be what's considered an actual licensed structural engineer, which that several areas past just your general civil degree. So that's really specific as well, and typically people that do that at least in those areas. We'll focus on that primarily and kind of be specialized in that. So to get to this point, obviously your company will produce design drawings that kind of, basically piece together the structure. So really from there, you would send it, at least in this case, it's, primarily a steel structure. So you would send it to a steel fabricator, and what they will typically do is basically model your structure for you and basically, piece it together. So I will kind of show you what that looks like, in this case, specifically for this building. So let's see. So you would send it to, a fabricator, steel company, and what they will do, they will basically take your drawings and produce a model of the drawings, kind of put it together, basically how it's going to be constructed in the field. So they will, they'll model it, and then really from there they will produce individual drawings for every single member in this. So you've got your columns, your beams, your girts around the building itself, that the siding is attached to, your bracing. So all that has its own detailed sheet. And really nowadays it's the technology is advanced. So really once they get this model, then create the details for each individual beam, they'll send it to a program, and they've got these big pieces of machinery that will basically take the drawing for the beam and basically construct it. They'll punch any holes where they need to be, and it's produced pretty quickly. So it's the efficiency's a whole lot better than it was in past, as far as producing these steel members and getting them shipped to the site. So anytime you can speed up the construction, your management group's always going to be for that. So, but this is typically what will happen in the process of the project, how you get from the initial design creation to the final product, so it's ready to construct. So it's always nice to see what you've worked on, design, go into a final product and be able to see it actually being built and constructed out on the job site. So move on from that. Let's see. Okay. So I guess one of the like I said, one of the things I like about this field itself is to be able to see what you've been working on, see it constructed, see, go out there and see it. Skipping back to kind of the education requirements, if really any engineering field you go into, once you get to your senior year of college, where you're close to graduation, I think a lot of the schools will require you to take what's called a fundamentals of engineering review course, and that's to prepare you for what's called the EIT exam, if you choose to take that. So that's consists of an 8-hour, 80-question course or test that you take, and if you pass that, you're considered an EIT, which is short for engineering and training. I think most of the engineering disciplines will go that path and take that test. So I think now all that test is all computer-based, multiple choice. So then typically from there, you'll graduate, you'll go work for a company, and then your next step, if you continue to pursue that, would be your PE license. So that's that would be another 8-hour, 80-question test that you would take. And if you were to pass that, uh, you'd be licensed in the state you took it in. And a lot of the states will, once you pass in one, you've got to fill out some paperwork, and you can be licensed in multiple states. Typically, before you can take the PE exam, you have to have 4 years of work under a licensed engineer. I think if you get a master's degree, they'll knock it down to 3 years before you can take the test. But that, and then from there, at least in the structural field, you can take, as I mentioned, the structural exam, and I think that's two 8-hour courses. So and in that you would either focus on the bridge perspective, or the building side of it. I think that's mostly about all I had to talk about. If we want to move on to any questions or comments or anything like that.
All right, McKenna has a question. Actually, she has two, so I'll let McKenna go ahead and ask.
What is the shortest and longest project you have worked on?
So the longest, I guess with the company I'm with now, I've been on 2 projects that are currently in construction. I guess the one started in maybe September of 2017. So we're coming up on 3 years now, and I'd say by the time it's completed and the building's up and running, it'll be 4.5 years that has been spent from conception into design and finishing up construction. Like I said, this company is a little bit different since it's all government work, and that typically drags out a lot longer than you would find out in the private sector. With my last company, I'm trying to think. I mean, you would have, design projects last a couple months. You get through that pretty quickly if you're able to, and then move into construction. And I would say that depending on the size of the project, last a year and a half. So it's hard, especially if it's a sizable project, to get everything done in really less than a year, I would say. Just all that goes into the design, and then shifting to construction and get everything, produced and shipped and then built in the field. And then you'll have to, get the facility tested out and up and running. So year and a half is probably pretty typical if you're on the short end of the time length.
Hey, Abby, you have a question.
How has COVID affected your job, if it has any?
Well, I guess the biggest effect is I've been working at home for I don't even know how long now. I think it's since mid-March, maybe. Other than that, for me personally, it's not affected too much. Other now, these projects, they've affected a lot of, as far as going to supply some of the material. A lot of, you've got a lot of steel and equipment. Where I'm at now, we get stuff from all over the world as far as equipment goes, and there's a lot of special requirements needed on that as far as welding, inspection, stuff like that goes. So more on the mechanical side, they have to do a lot of traveling to do these inspections. So that's kind of caused a lot of issues from that side of it. We've had stuff, out in Washington State, that in Canada, I think over in Europe. I'm trying to remember exactly where that we're supposed to have trips to inspect some of this equipment that's been put on hold, and of course that results in delay in the project, which nobody wants. But I think this is an interesting new time for everybody as far as work, school goes. So you just kind of have to adjust on the fly and make the best of it and do what you can. So I guess that's probably been the biggest effect on my job. Luckily, a lot of engineering now is done on computer programs, so a lot of that can still be done at home. And of course, with Zoom or other software like that, you can still have meetings. And so luckily, the technology has helped out with a lot of it.
How many computers do you have going at one time?
At the office, I just have one. We've got with dual screen, so that's really nice. Coming from previously only having one, switching back and forth between programs. Now you can have one program running on one screen and then another one on the other, and just go back and forth. So that helps make it a little bit easier and more efficient, I guess.
I only ask because I have two working from home. You have to juggle. It's so different than being in your workspace. So it's just a funny question. All right. McKenna has another question.
What's your least favorite and your favorite project that you have worked on?
Oh, least favorite. I don't know that I could say I had any really least favorites. Really, just because they've all been pretty unique. Of course, you're going to have problems come up on each project. Where I'm at now, I guess I would say the least favorite part of it would be that this facility is 75 years old, and a lot of the buildings and the underground stuff are the original materials of construction. So a lot of the documentation on some of that's not been there. So as you get into construction, there's always going to be stuff you didn't know about that you've got to solve pretty quickly, and to keep the project on schedule and moving forward. My favorite, I guess, would probably be the one I just showed you some pictures of. Just that was pretty good sized project. That was, I guess, my first real major project that I worked on by myself, I guess. So to see that through from the beginning to the end was pretty nice to see. And then the two I'm working on now, once they get complete and everything's up and running, those will have been good projects as well.
I don't think that was your first project, by the way.
Well, no, I mean, it was the first, I guess, one I was responsible for myself. Before I'd work with, some of the other engineers helping them out. But
well, didn't you, in high school, didn't you design the sign at Crockett, like the?
I may have, but I don't remember, honestly.
I'm pretty sure you did while we were. I don't know what year that sign was put up. So if you go to Crockett and that sign that is up, I'm pretty sure Ryan did that. He would never admit to it though. All right, McKenna had another question.
What is the hardest part of your job?
Hardest part, I guess, time management's always something you have to be worried about, especially if you've got multiple projects you're trying to juggle. Working with other engineers is obviously always somewhat of a challenge. You've got different inputs into the project. You have to work closely together, communicate. That's obviously always key. Make sure everyone understands, parameters, um, your specifications that go into the project. You have one slip up that can roll downhill pretty fast and affect everyone involved if you're not careful with it. So just making sure everyone's on the same page and communicating well is, very important in, an engineering project like this, to make sure, because, you don't want to put anyone's health or safety in question out there as construction's ongoing, and then once it's in operation.
Does anyone else have any questions that you want to put in the chat, or you can unmute yourself and ask too? They're all so quiet.
Well, it's Monday morning. I got a question.
All right.
So, transition over to COVID, we already talked about it a little bit, but the day-to-day process of just like associating with other people, has that made it significantly harder on you? Because I worked in an engineering firm for a while, and if I couldn't go talk to one of the engineers, my day was shot. So,
well, personally, I'm more of an introvert, so I keep to myself in general. We've got Skype and, meetings, that we still engage each other with if, we need to talk about something or just complain in general about whatever. So, without the technology, it would, be quite a bit different, and, you would not have that engagement that you would typically have in the office if, during a project, or, just the course of your regular day, to just go talk and, bounce some questions or ideas off your fellow engineers if any come up. So, I guess, since most of these two projects have been in construction for me, there's not been, I guess, as much involvement with other engineers as far as, you would expect during a design. So that's been a little bit less, I guess, as far as interacting goes.
okay, I was just curious with the day-to-day, how that changed, because it changes with every field tremendously. So. Cool, thanks.
And welcome.
I was actually surprised he agreed to speak for us. That's how quiet he typically is. So I'm going to vouch for him on that one.
Well, I'm all for trying to encourage anybody to get into the engineering field, or really anything STEM related now. The more people, the better, from my opinion.
Okay, so we're going to take that introvert thing and go with it for a minute. So Ryan and I went to Crockett, and Crockett is a larger high school in our area. And I know if you're from Greene County, you come from a very small high school. There's about 1,200 people at Crockett. Tell us what it was like moving to Knoxville for you, and just that general experience of being somewhere so big.
It wasn't, I guess for me, wasn't too big of a deal, since I initially went down there with some people I graduated with and my younger brother as well. So it, if you have people, it certainly makes it easier. Really, time management's going to be key as you transition from high school into college, and, especially if you move away and live in either on campus or right off campus, you're going to have a lot more responsibilities than you would maybe at home. You're going to have to make sure you get yourself to class, do homework, don't spend so much time in the at the parties and whatever else you can get into that could take away from making sure you continue to do well in school. So just, make sure you can manage your time and focus on school. There's always plenty of time for everything else. So, but I don't guess it was too big of a deal for me. I went to class and just kind of kept to myself. I mean, you'll you'll get in some classes, at least once you start out in your general courses, that, you know, you'll be in an auditorium of 300 and 400 people just sitting there listening to a professor. I guess that would, you know, be one of the downsides on a larger university is just the class sizes in some of them. But once you get into your major, I mean, you're down to 15, 20 people in a class, so it's not near as bad once you start focusing on your actual degree itself. So.
Okay, so you're like painfully much smarter than I am, and I always will know that. But when you went to UT, did you ever feel like you weren't prepared or like you weren't smart enough to sit in a class with 300 or more people?
I don't know if I would say I wasn't prepared, but there's certainly times you know I got overwhelmed. There was one, I guess, semester in particular that I didn't do so well in, and I actually applied at ETSU just in case I decided I wanted to come back and, you know, change paths. But, you know, everything worked out and I passed all the courses. I'll leave it at that. So once I got through that, you know, everything worked out and was fine. But that's to be expected to some degree. I mean, it's really it'll be a new experience for everyone. Once you step foot on college, it's, you know, you're kind of on your own as far as making sure you do what you need to and get everything done. They, you know, I won't say they don't care if you show up or not, but they're not going to force you to. So.
And they're not going to like send out reminders of, hey, you didn't do your homework. Will you make sure and do that? Or I think that has been one of the biggest things to try to help people prepare is just making sure they realize how independent and responsible you must be. Okay, does anybody else have any questions? I have a few written down that I'll ask if not. I can see. Okay. All right, so this one is not intended to be nosy, but so we're not talking about your salary, but in general, how much do civil engineers make, like a ballpark?
I think typically starting out, and a lot of this you can Google, and you know it will depend on the area and your discipline that you get into, whether it's civil, mechanical, electrical, chemical. You're typically starting salary, at least in this area, you know, you'll expect between 40 and 50,000. Of course, that's right out of college, so. You know, if you go different areas, I would imagine it could be slightly higher. Just, you know, the cost of living around here is pretty significantly low than elsewhere in the country. So I'd say that's probably a pretty competitive starting salary for really any engineering field. And of course, you know, to add to that, sorry, Heather, you know, if you pass your EIT exam, that's always, you know, a positive that you can put on your resume and may obviously be a negotiating tool for higher pay. And then, of course, if you pass your PE exam, that's probably the biggest deal that, you know, allows you to potentially, you know, make more money. But I mean, that's several years down the road once you've started it out, that would be taken into account.
Okay, my next question is, I've heard a lot of times, like with engineers, you don't really need like a doctorate or anything, that typically most engineers will go for maybe their master's and then stop and that just be their highest degree because they feel like they don't need anything more. Is that true, or?
Well, I guess it will depend on your career path. If you want to get into something, you know, research, testing, stuff like that, you would typically pursue, you know, above a master's. But if you're doing that, you're probably going to be working on a campus or a research facility. You're not going to be necessarily out in the field practicing. Really, if you just want to get your degree and then move on and start working, the 4-year degrees, typically plenty. Really, it's there to give you the foundation and the background on your field. Once you move in to start working, you're going to learn tons and tons more, and it'll be more specific depending on what you're actually working on. So, I mean, if, master's program, I think, are only an extra year. And I think UT, they would typically cover the cost. You'd work under a professor or a faculty member and, work on I think a research project or something as part of that. So, obviously, if you pursue engineering field, definitely engage the facilities professors, whether it's just a 4-year degree or master's or more. There's resources there. They want to, help you out in any way they can. So don't be shy about asking questions, finding out more information to help, make your decision a little bit better and easier going forward.
Would you say that your college experience was more hands-on, or were you doing a lot of writing papers? And because we've heard different things from different professions, so we're just kind of curious.
I guess from an engineering standpoint, there's not a lot of papers. You'll have, reports, lab reports. I know at least as far as civil goes, we had a lot of different labs as far as running testing. We had a materials lab. You test different materials, whether it's concrete, asphalt. Then you'll have your general chemistry labs. Trying to think what other labs I had. Then we had a geotechnical lab, so we did a lot of, soil testing, running, the typical tests they'll run out in the field. I think I took a surveying course. So you go out there and, learn basic surveying, stuff like that. So I don't think, you'll have, reports to write, but most of your stuff is going to be more on the mathematical equation side, where you've got questions, you've got to solve problems, stuff like that.
Okay. And then our program is heavily dominated by females usually, so our boys are outnumbered. But are there a lot of females that enter into civil engineering? Have you run across?
Typically the engineering field is kind of the opposite. It's usually male dominated. So it's good. I don't know what a lot of you all are interested in, but if you're interested in engineering, that's certainly a plus. Get more females involved, different perspectives, point of views. I think where I'm at now, combined, we've got mechanical, chemical, electrical, and civil. There's 3 females, I think. We had one civil that worked with us for a little while, but she left a couple years ago. So it's probably maybe 5% females, at least where I'm at now. So that's, mostly males. So I would certainly encourage anyone to get involved, just so we can, have a better balance. And
I think it's too, in our area, you just don't hear of jobs like that. And I think that that's something that maybe, hopefully something like this will help.
I guess outside of Eastman, you typically don't hear of too many engineering jobs, maybe TVA to some degree, but between that and then this area, focused a lot on the medical field. That's where I think you would find a lot of concentration in students that are pursuing degrees. So, which, I mean, that is something important to keep in mind if you are looking to stay in this area to get a job once you finish up school, is to look what is available, because you don't want to get a degree and then can't find a job. That's, nobody wants to have to deal with that. So, if you don't care to move, there's opportunities all over the place. I know Knoxville's had tons of hiring even now. So, that's not far away, but it's still, away from where you've lived and grown up. So it would be change.
We do have a few students from Hawkins County and Hamblin County areas, so it wouldn't be so bad for them. Like, that's not a huge difference. So. All right. Does anybody else have any questions? Ryan, thank you so much for your time, and we really do appreciate you taking the time to speak with us. I guess really because of COVID, we actually had this opportunity because you're home. You probably were looking for something to do.
Something different than sitting at the computer all day is always nice, especially right now. So last thing to add there, if you have access to Netflix, there's a short video, it's about 40 minutes long, that kind of goes into a little bit more of the civil engineering field, that was actually produced by the American Society of Civil Engineers. I believe it's called Dream Big. If you have some time to kill and want to have interest in civil engineering, that would certainly be something to check out. And I think they have additional resources online. If you probably just Google it and stuff will come up. But worth watching if you have any interest at all, I think. So
I definitely will be watching it, just because I think about all the different careers that I was never exposed to. Like, I just had no idea that they existed. So thank you. All right. Anybody else?
Is that special narrated by Jeff Bridges, the Jeff Bridges?
Dude,
That is awesome. Jeff Bridges, guys. Go watch it.
Oh, Lucy has a question. Go for it, girl.
Okay, so I don't really know how to type this, but you sound like you use a lot of math in your job. Do you use things like the Pythagorean theorem actually in your job?
the colleges probably wouldn't like me saying this, but if you pursue an engineering degree, you're going to take a lot of math courses, lots of calculus, stuff like that. And unless you're pursuing a master's and even maybe more so a PhD, you're never going to use that math again. There's a lot of geometry I use in my field, lots of, angles, degrees, but really, it's basic, structural equations, steel, concrete, stuff like that. It's really focused on my field. You won't, at least not for me, I've not used a lot of general math at all. So, get through those classes as best as you can, and, obviously do well and pass, but, apply your focus really on the degree, the fields within your degree itself, I would say. So, because that's really what you're going to use once you get through college and start working is that background and those equations. And not to say math's not important, but
Okay, thank you.
a lot more advanced than most people will ever have to bother with once they start working.
And Ryan was a super studious student, like super smart, like you all. All right.
I got math until I got to college, and then it was not as much. So
Okay, so you all have a class right now. So I sent a message just saying, hey, we're finishing up the career speaker. So if you got to run to the restroom or something, go for it. You're dismissed, but hop on to your class as soon as possible. Thank you, guys.
One last thing, Heather, if anyone has any questions, feel free to give them my email and
Okay,
I'll be
perfect.
happy to answer any other questions they may have. So
That sounds perfect. Thank you so much for speaking. I don't know many engineers, so I feel privileged. All right, I think we are good. And I have your W-9. I think I already turned it in. I'm pretty sure I sent you an email back saying I did. Okay, so that'll be taken care of on Tusculan's end.
you need anything else from me, just let me know.